Hello everybody, my name is Peter Klapper from the School of Biosciences at the University of Kent in Canterbury. And in this video clip I want to show you one of the biggest problems that people usually face when they work in a laboratory. It is about preparing solutions and how to do the calculations for that. And I will use the dimensional analysis method. This has the huge advantage that you don't have to learn any complicated equations or anything like that, so you just have to watch your units for this particular task. So let's assume we want to make, say, 125 milliliter of a particular solution. Let's say we want to have 50 millimolar solution of sodium chloride, and we can look up the molecular mass of sodium chloride. This is 58.44 gram per mole, so that is sodium chloride, and we want to know how many grams do we actually have to weigh in order to get this solution. So the first thing that we need to do is we write down the unit of what we are looking for. So we are looking for the weight, and that would be in grams. This is just simply to not lose sight of what we are actually looking for. The next step is a large sort of line. This will be our fraction line. And we then do a simple dimensional analysis, and this works in the way that we say, okay, what do we know? We have this information here, and actually this last one, this molecular weight, actually has the unit that we are already looking for. So what we do is we write this information down, and we make sure that the unit that we are looking for is on top of the line. So we have 58.44 gram. So it is on top of the line, and that is actually what we are looking for. And we know that this is in 1 mole. Now, what we want to do is we want to get rid of this mole down here. So ideally, we would like to have a mole up here. And the way we can do it is we know that all our things are here in milli. So we can say 1 mole. And you see, we've got a mole here and the mole here. So what's down here in the denominator goes into the numerator. 1 mole equals 1,000 millimole. Something like that. And we want to have a 50 millimolar solution. So this means 50 millimole per liter. Now we've got a millimole down here, so we would like to have the millimole up here. So we have 50 millimole in 1 liter. Okay, now we want to have the amount of milliliters that we have here, and again we have it in milli. So we've got 1 liter there, that's down here, so we put that up here. 1 liter equals 1,000 milliliter. I have to extend my fraction here. And what we got? We have 125 milliliter. So oops, the 5 got missing, 125 milliliter. So, and we are more or less at an end. So what can we do? So we've got our gram here. Now we can cancel out things. We have mole, that cancels out here. We can cancel out the millimole and millimole. We can cancel out the liter and the liter, and we can cancel out the milliliter. So all we have left is really this gram here. So what do we need to do? We just simply write down what we've got left, 58.44 4 gram. We always take the units with us. Times, we can completely ignore this part here. We have 50 here, times 50. We can ignore this one here, times 125. Divided by, what have we got left? The one here we can ignore. We've got 1,000 here. And we've got another 1,000 here. So all we need to do is calculate these things, multiply them together, and we get 0.365 grams. So this would be our answer. You don't need to know any complicated equations. If you just simply do it this method, then you, by default, you can't go wrong, and you always get your correct unit. So thank you very much for watching, and in future videos I will give you some more examples of this very neat method.